I put together and tested this sort of breadboardish version of a tracking power supply. And I used this transformer. The reason I chose this toroid, which has two 20-volt secondaries, rather than two individual transformers, was because 24 volts, which is the most commonly available standalone conventional transformer, is too much voltage for this. And also the bob and wound transformers seem to, at least the ones available today, seem to have poor load regulation. Their output voltage swings violently with load. This thing has tolerably good load regulation, and 20 volts is the perfect voltage for this device. So you see, this doesn't conveniently lend itself to a case. Now I'm going to take these two fans off. I guess I could, without the fans, I could mount the board like this and put some fans on the back of the case. And I still need some room up front here for front-mounted devices. So I'm going to try to use this case, which may be overkill. I wanted to show this case first. This case is an example of the Chinese trying to copy an American product. I believe this to be a copy of a Pac-Nor style clamshell case. In the case of the Pac-Nor, well, let's back up a little bit. A standard clamshell case has a top and a bottom, and then a front and a back, and miscellaneous screws and whatnot. This case is sold to be adjustable in height. In other words, the top and bottom just don't come together when the screws are tight. There's a whole bunch of spacers. Well, there's a total of 16 spacers, which means we can use up to 4 spacers per screw. The screws, however, come extremely long, but there's lots of thread on them that needs to be cut off if the cases are something other than maximum. And what do we do to fill in the side hole here? Pac-Nor does not furnish a front and a back. It's up to the case user to furnish a front and back. But Pac-Nor provides these side panels. So once the side panels are installed, or a side panel, we can vary the height of the enclosure. See, the side panels will slide up and down. In order to ensure the side panels are centered, we have to put spacers in. And according to my notes, we had, or used to have, 16 spacers. This has been laying around for quite a while. And we do have 16 spacers. And also, according to my notes, if we use all 16 spacers, it's 100 millimeters from here to here. And with 8 of the long spacers, it's 90 millimeters. 8 of the short spacers is 80 millimeters. And no spacers at all is 70 millimeters. So this can have a case height of 100, 90, 80, or 70 millimeters. When all the spacers are installed, we end up with a 100mm case, and then it gets shorter in increments as spacers are removed. Banggood elected to supply front and rear panels. The front and rear panels only fit when the screws are loose. The spacers are not installed to solve. To achieve the dimensions that the panel was sold with, that is, all spacers installed, screws tight, these side panels forced to be centered, it becomes necessary to trim off at least 5mm of the front and back panel. And incidentally, as it gets shorter, the screws need to be shorter, because the screws are just long enough so I can tighten it up with all the spacers installed. So it's a poorly implemented knockoff of Pacnor case. Because I don't know what my front panel is going to look like, I'm not sure whether I'm going to use analog meters or digital meters. I'm either going to just wait a while to trim the front, or I'll trim 5mm of it off in order to achieve the 95mm panel height, which will give me the 100mm case height. And this is for Banggood. Here's the dimensions that Banggood advertised. And here's Banggood's advertisement. Expensive little fellow here at $27 plus 31 cents shipping. And you can see it comes with a top and a bottom, 2 side pieces, and a front and a back. It also has a bail that can be attached, and it's a little bit tough to snap the bail up, but you can do it. It will stand up on the bail and give you a tilted case. Now, if this is a power transformer I intend to use, it has 2 20-volt secondaries for a total of 40 volts. And it's rated 100 VA. I should easily be able to draw 1 amp from each 20-volt secondary. That'd be 40 volts at 1 amp, which would be 40 VA. I have 100. So I've got lots of headroom. But I need to be able to power the fans. And if I need to power a digital display, and that's up in the air right now, I need between 5 and 24 volts DC, in addition to the 2 20-volt windings. One nice thing about a toroid is that it's easy to add turns to. I've got this bundle of what was once a continuous length of yellow wire. It's silicone. However, I opened the package with my scissors, and I created a bunch of miscellaneous lengths. So I'm going to take some of this yellow wire, just because just because. So before I plug it in, I've got 4 turns through the aperture here. If you count the outside, you'll see there's 3, but this counts as 4 turns. These Wagos, or Chinese knockoff Wagos, are really handy to have. This I use for power distribution, and these I use just because I had to seal up the end of the secondary. And I didn't want to short anything out. I didn't want to have to use a piece of tape, so I just lift this lever and I'll be good to go. 4 turns, I'm going to plug it in. And 4 turns gives me almost a volt. I'll take that off. I'll put another turn on. And you see we have 5 turns, 1.2 volts. So for every 5 turns, well really if I divide 5 into this number, I'll get the volts per turn of this transformer. So 5 turns equals that. 10 turns would be double that. Now the turns are going to be wound on the outside. They're pretty loose right now, but I'll be more snug and I'll wrap them probably to use an equal amount of area, just so when I bolt the thing in it's not bunched up. It doesn't matter. But now that we know the volts per turn, we can determine the number of turns we need to get a certain AC output voltage. I don't need to use enameled wire. They use enameled wire in the transformer because it takes up less space. I'll probably use number 20. I only plan on drawing an amp or an amp and a half. And it'll be spread around, and if I use this silicone wire, heating is not a problem. I have lots of VA left unused. I'll probably do this to derive to create a third winding, because I'm going to use 1 winding for the negative side, 1 wire winding for the positive side, and then use for incidental things like fans and maybe digital indicators. If you have any interest in seeing how this is all going to pan out, keep track of, it'll be version 3 of the tracking power supply. Thank you.